Hey guys, today we are continuing with our motion unit and we're going to be able to describe motion today. So we're going to be taking a look at acceleration and velocity. Now I will say if you did not do yesterday's lesson on distance and displacement, you need to go back and do that first because we're going to talk about that again today. And if you don't know what it is, this is going to be a little bit confusing to you. But if you've already done distance and displacement, go ahead and move forward and we'll get started with today's lesson. Oops. All right, so just a review of what distance and displacement are. Distance is how far something has moved, and displacement is the change in position of an object. Both of these are measured in meters, so we're going to be using the International Standard units, so kilometer, centimeter, millimeter, etc. But remember, distance just has that single unit, and displacement also needs a direction. So distance is a scalar quantity, displacement is a vector quantity, so it needs both the unit and the direction of the displacement as well. So now let's talk about speed and velocity. Speed is how fast something is traveling. So a lot of times when we think about speed, we think about the speed of a car, maybe an airplane or a train, something that's traveling. Velocity is an object's speed and direction. Okay, so when we measure velocity, it is the displacement over time. And the formula for this is V is equal to delta D. And delta just means change in something. So delta D is the change in displacement. And then over delta T is the change in time. Okay, so delta T is going to be the change in position or the displacement over the change in time. And this is measured in meters per second. Okay, so if we're taking a look at the formulas, if we were going to calculate it, speed would be distance over time, so the total distance divided by the time, and this is a scalar quantity, so there's no direction. So this would just be, meters per second. That's the only unit you would use. Velocity is displacement over time. Okay, this is why I said you need to know how to calculate distance and displacement from yesterday's lesson, because if you don't know how to calculate displacement, you can't get velocity. So velocity is displacement over time, and this is a vector quantity, so it needs direction. Okay, so your velocity would be meters per second east, meters per second west, okay, because it is a vector. So when we graph velocity, and remember velocity is that vector quantity, the independent variable is going to be the time. So our independent variable is always graphed on the x-axis, and the dependent variable is going to be the position, which is always graphed on the y-axis. So the position is changing in relation to the time. So as time moves forward, our position is changing. The slope is going to be our velocity. Okay, so again, velocity is the displacement over time. Okay. And then same thing with changing velocity. So again, our position is on our y. It's going to be our dependent variable, and then our time is going to be on our x with our independent variable. And these are some examples of what a velocity graph could look like, and based on what we see, it can tell us a lot about the object that is moving, right? So this could be a car, it could be a person walking, just an object with motion. So if you see this straight kind of constant line here, this is going to indicate a fast, steady speed. Okay, so whatever object is moving quickly, and it's moving at a steady rate. This red line right here, we see some changes in this. So we've got a steady speed to start with. So it looks similar to that green line. So we have a steady speed. And then here, if you see there's no change, so this line is indicating that whatever object was moving has come to a stop. Okay, so if you're driving a car, maybe you are driving along and then you come to a stop sign or a stoplight and have to stop. Because there's no slope here, there's no velocity. So we're not changing position, we're stationary, okay? Then this decrease is a returning to the start. Okay, so returning to the start, back to wherever you originally started from. If you see this kind of curved line here, this is showing that the object is speeding up. Okay, so this was a steady rate. A curved line would be showing that there is a change in the overall speed and that the speed of that object is increasing. So just to review the difference between a scalar and a vector, so some physical quantities can be fully defined by specifying their magnitude with a unit, but others also require their direction to be specified. So a scalar quantity has magnitude, aka a unit associated with it, so like a meter, centimeter, millimeter, but it does not have a direction, okay? Vector quantities have both magnitude and direction. So if we're talking about displacement or we're talking about velocity, a direction is going to be needed to be included in the answer, okay? So scalar values are distance and speed. So how fast is something going, and then what distance is covered. So these are measured in just a magnitude unit. And then vectors are going to be displacement and velocity. So remember, displacement is where you end up in relation to where you started. And so this would need a direction associated with it. And then velocity as well would also need a direction associated with it. And you're going to see that more in your assignment for today, but we do need to know that distance and speed are scalar values and displacement and velocity are vector values. Okay? So today's lesson was pretty short, just introducing that idea of speed and velocity. You're going to do some calculations in your assignment for today, so that's where you're going to be getting the bulk of your practice. But if you have any questions on your notes, definitely let me know.